CloudCIX is an open source, multi-region, multi-tenanted cloud platform. CloudCIX is scalable. You can use CloudCIX to build any size of cloud, from a few servers in one region to thousands of servers located in multiple regions across the globe. We will describe CloudCIX architecture and then show you how that architecture can be used to install public and private clouds. We start by describing how different flavor pods are combined to build clouds for different needs. CloudCIX is built in hardware pods. There are three flavors of pod: a provisioning and telemetry, or PAT flavored pod, a central orchestration platform, or COP flavored pod, and a region flavored pod. A pod can have one flavor or can be a blend of two or even of all three flavors. A region flavor pod is where the user's cloud infrastructure is built. A region has hosts that contain the compute and storage resources available to the end users. A central orchestration platform, or COP flavor pod, provides the user interface for users and provides the authentication, authorization, and accounting for the cloud using the CloudCIX application membership. The COP contains the metadata that describes the user infrastructure built in the region, and, as well as a UI, the COP also provides an API to allow automation. A single COP can orchestrate multiple regions. This allows for geographically distributed cloud. For large clouds, you can optionally have a provisioning and telemetry, or PAT flavored pod, that manages and monitors COPs and regions. Of course, one PAT can manage and monitor multiple COPs and regions. Okay, while we're looking at this schematic, let us talk for a moment about private cloud. A business can have a private region with dedicated hardware for their needs. This means that workloads from other businesses cannot interfere with the performance of the private region. A business could have a private COP and a private region. This adds an extra layer of security because the metadata for the cloud is physically separated from metadata for other clouds. A single COP can control multiple regions, so in effect, CloudCIX can be used to build a federated private or public cloud with resources in geographically diverse regions. Putting all the pieces together, this schematic shows the relationship between one PAT serving multiple COPs, each serving multiple regions. This architecture allows you to create any desired private or public cloud at any scale. So, we've just described how CloudCIX pods are combined to build private and public clouds. We explained that there are three pod flavors: PAT, COP, and region, and that a pod can be any blend of these flavors. Now we're going to explore the architecture of a single pod in detail. All pods are architected similarly, but can be physically very different, depending on the resilience and scale required. In this video, we're going to describe a simple pod and not focus on resilience or scale. This diagram is an overview of a CloudCIX pod. Let's break this down in more detail. A pod needs three types of server. A podnet server implements networking functionality such as routers, firewalls, and VPN tunnels using Linux network namespaces, also called VRFs. A server called a pod appliance runs the CloudCIX software in Docker containers. Each pod flavor requires a different set of Docker containers. The fundamental difference between different pod flavors is which Docker containers are running on the pod appliance. The region runs containers that implement the user-requested infrastructure. The COP runs containers that implement both the underlying API and the user interface. Together, these allow the user to declaratively define the infrastructure required. The PAT runs containers that manage the configuration and deployment of other pods that have regions and/or COP flavors. If the pod runs cloud projects, then one or multiple hosts will be installed. These hosts contain the VMs that make up the projects and vSwitches to connect the VMs to the private network. Hosts can run KVM or Hyper-V virtualization. Hosts can also run GPUs. If the pod has a PAT flavor, then the telemetry functionality is implemented by way of projects running on hosts. So, in effect, the PAT is a cloud and is used to provision and monitor other clouds. Or, to paraphrase J.R.R. Tolkien, one cloud to rule them all. Every pod requires a switch fabric to build the three networks. The public network connects PodNet to the public internet. The private network connects VMs within a project and then connects the project to PodNet. The management network connects the pod appliance to both the PodNet and the hosts. We mentioned that a pod can have three networks: public, private, and management. Those three are all that is required to build a basic cloud. However, commercial implementations usually have two other networks: the out-of-band or OOB network and the Ceph cluster bus. Most hosts have management ports that allow monitoring and management of the underlying hardware. Depending on the vendor, these ports are called IPMI, IDRAC, or ILO, and they are connected via a network referred to as an out-of-band or OOB network. Typically, the path connects to the OOB network via a VPN tunnel and uses the OOB networks in all of the pods it manages. CloudCIX supports Ceph RAID storage. Ceph requires two networks, and in Ceph documentation, these are called public and private. Just to confuse everybody, the Ceph public network coexists on the CloudCIX management network and not on the CloudCIX public network. And the Ceph private network is referred to as a cluster network in CloudCIX documentation. That's it for now. Thanks for watching.